Hello everyone, welcome to this second lesson of complex numbers. Before we go ahead with today's topic, which is the Argand diagram, I want to give you the solution to these problems which I left in the previous lesson. Let's get into it. So 1 over minus j power 7. This can be written as 1 j squared power 3 multiplied by j. We know what j squared is. This can also be written as 1 over minus 1 power 3 multiplied by j. So this is 1 minus j. Now we multiply the denominator and the numerator with minus j. Finally we get our answer as minus j. In our coming lessons I will show you why I'm multiplying both the numerator and the denominator with minus 1. Don't worry. So that's the first answer for number 1. Let me tackle number 3 before I get into number 2. So 4 over 2 j squared over 23. This can be written as 2 will cancel 4. This will be 2 all over j power 2 is to 11 multiplied by j. I've just written the denominator in a different way so that you can see it clearly. This is identical to 2 all over j squared is minus 1 raised to power 11. It will be minus 1 multiplied by j. So this will be 2 over minus j. Multiply top and bottom with j squared with j. This will give us 2j. That is the answer. Once again, I will show you why I'm doing this in our coming lessons. Don't worry. So number 3, the answer is 2j. Number 1, the answer is minus j. And now let's tackle number 2. 25x squared minus 10x plus 2 is equal to 0. So I will use the quadratic formula. This will be x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Our a is 25, b is minus 10, and c is 2. Okay, now we chug and plug in our equation. This will be minus bracket minus 10 plus or minus square root of minus 10 squared minus 4 multiplied by 25 multiplied by 2. Okay, all over 2 multiplied by a 25. Okay, this can be simplified as 10 plus or minus square root of 100 minus 200 all over 50. Okay, continue. This can be simplified as 10 plus or minus square root of minus 100 all over 50. So 10 plus or minus square root, again we pull out the minus 1, 100 times minus 1 all over 50. Okay, now we are left with 10 over 50 plus or minus square root of 100 multiplied by square root of minus 1 all over 50. We can cancel the zeros. This will be 1 over 5 plus or minus square root of 100 is 10. 10 divided 10, the zeros will cancel, will come 5, and root of minus 1, we all know it is j. So those are the roots to this equation. Those are the solution to the previous lessons, exercises of which I left, so you can test yourself with. So good, let's move on to today's agenda, which is the Argand diagram. Okay, so Argand diagram. Okay, today we're dealing with the Argand diagram. The Argand diagram, it is a graphical and Pictorial. It is a graphical and pictorial representation It is a graphical and pictorial representation of complex complex numbers on rectangular and Cartesian axis. The Argand diagram. It is a graphical and pictorial representation of complex numbers on rectangular and Cartesian axes. So, for example, let's say you're given these complex numbers. So you're given 2 plus 3j you're given minus 3 minus j, and you're given minus 1 plus 2j, and you're given minus 3 plus 2j. For instance, let's say, for example, you're given these 4 complex numbers. And you're asked to represent them on an Argand diagram. So this is how an Argand diagram looks like. This vertical axis is referred to as the imaginary axis. That is where the imaginary part is represented, and the horizontal one is the real axis. So on the horizontal axis we have the real numbers 1, 2, 3, 4, minus 1, minus 2, minus 3. Vertical, we have the imaginary part. This is j, 2j, 3j, 4j, minus j, minus 2j, minus 3j, minus 4j. Okay, so and remember you're asked if you're asked to represent these complex numbers on this is what we call the Argand diagram. Represent it on this diagram. Let's say for instance 2 plus 3j. You will go, you know that the real part is 2 and the imaginary part is the imaginary part is 3. So this will be our complex number 2 plus 3j. That is how it is represented on an Argand diagram. Let's represent this one, minus 3 minus j, minus 3 minus j. Again you'll do the same thing, minus 3 minus j. Minus j is here, so drop that, minus j, drop that like that, and draw a line to where they meet. Now that's our complex number, minus 3 minus j. The other complex number, minus 1 plus 2j. If we were to represent that will be minus 1 plus 2j. And drop, this is 2j. That is our complex number. It will be our complex number, minus 1 plus 2j. And the last one, if we were to represent that on a new Argand diagram, it is minus 3. Minus 3 is here. Minus 3 plus 2j. Minus 3 plus 2j, drop, minus 3 minus 3 plus 2j. Okay, minus 3, 2j is up here. That will be our minus 3 plus 2j. So we have represented 4 complex numbers. Let's add the fifth one. Let's say you're told to represent minus 4j plus 3. Minus 4j plus 3. Okay, minus 4j will be here. 3, the real part is 3. Minus 4 will be here. So the complex number minus 4j plus 3 will be presented by this. Complex number 3 minus 4j. Okay, that's how you represent complex numbers on an Argand diagram.